In this unit on sequences and series, we encounter a number of different types of sequences, including arithmetic sequences and now something called geometric sequences. So when we looked at an arithmetic sequence, we found that the terms had a common difference between them. It turns out that when we have geometric sequences, they have something common between them as well, but not a common difference. Instead, they have a common ratio. And the way that we find the common ratio, R, between the terms, is that we'll divide the second one by the first one. We'll do something like A2 divided by A1. And in this case, that equals 9 divided by 27. And when we're finding the common ratio, it's certainly reasonable to reduce. So if we cancel the 9 on top with the 27 on bottom, we get 1 over 3. So we certainly have a ratio between the second and first term of 1/3. The only thing is we don't know whether that's a common ratio until we check other terms. So we'll go ahead and check. What about a sub 3, the third term, divided by a sub 2? It will always be a particular term divided by the previous term. So in this case, we could try something like 3 divided by 9, and sure enough, you get 1/3. Okay, so what we've identified is that at least these first three terms have common ratios between them of 1/3, and so we'll make the assumption at this point that this is a geometric sequence. If we found that these two did not have the same ratio between them, we would say not a geometric sequence. Now, something else that I want to point out that's very interesting about this common ratio is once you discover it, you find it by dividing a term by the previous term. But something interesting about the common ratio is that it actually is a multiplier. In other words, to get from the first term to the second term, you multiply times r. To get from the second term to the third term, you multiply times r. And to get from the third term to the fourth term, you multiply times r. So once you know the common ratio, it's simply what you multiply each term by to get the next term. Now, with arithmetic sequences, we would always have the same sign for the terms, or at least they wouldn't alternate. You'd have a positive sign, and if it ever went negative, it would then stay negative. Or you'd have a negative sign, and if it ever went positive, it would stay positive. Or it would just always be positive or always be negative. But with geometric sequences, it's possible to have alternating signs. Let's take a look and see why. Let's see if we can find the common ratio of this next sequence. So what if we look for r, and we say a2 divided by a1, a sub 2 divided by a sub 1, the second term divided by the first term, and we'll do 2 divided by -1. That gets us -2. Let's try another one. This time I'm going to do -16 divided by 8. And when I do that, sure enough, I get -2. So I have some confidence that I have a common ratio here, and the common ratio is a negative number. Now, as I said earlier, the common ratio is also the thing that you multiply each term by to get the next term. And you'll notice -1 times -2 gets us +2, and -2 times +2 gets us -4. In other words, if we have a common ratio that is negative, we're going to get alternating positive and negative terms in our sequence or our series. All right, I think that's about all I wanted to say for identifying geometric sequences and series.